My name, as you said, is Nicolas Tendre. I'm working for Firecell. Firecell is a company based in France, and I'm currently located in France. And I'm very happy to be with you today. As I said, I'm very honored to present this. If you want to have a look now or later at our website, it's displayed on the screen, firecell.io, and we also have a LinkedIn page where you can also subscribe to our posts or go there regularly and have some information of what we're doing in the world of RAN and Open RAN. Today's presentation will be on Open RAN and 5G for the industry. I'll start with a presentation of Firecell. Then we'll talk about private 5G networks. I'll show you a couple of industrial use cases. And then we'll talk about open source software, and more specifically, the open air interface software that's also called OAI as an acronym. We'll see a few architecture options that are enabled by Open RAN and that are implemented by OAI. And before concluding this webinar, I'll show you just a slide about Firecell's offering. So I hope you will enjoy this presentation. I suppose at the end, you'll be able to ask questions. I'm not the most technical guy of the company, so I apologize in advance if I cannot answer all of the questions, but I'll be happy to take them over if I cannot answer them online and get back to my research team and get back to you either by email or through any ways that the Academy can provide for answering questions. Well, let's start with a few words about Firecell. So Firecell is a startup, and we're very happy to be partners of Asia RAN Academy today, not only today, but presenting today. Firecell was created about 2 years ago in May 2021 in Nice, in the south of France, including Eurecom. Eurecom is an organization and a research center very close to Nice. And Eurecom is one of the founders of Firecell. And they're one of the reasons I'll be talking about open source today, because Eurecom, as I'll explain a little bit in more details later, is the inventor, in a way, of open air interface and implementation of 5G core and 5G RAN in open source. Firecell, let's get back to Firecell. Today, we're about 27 people. We're growing very fast. We have people in France, in India, in Sweden, in many different countries, not yet in the Philippines, but I hope it will come soon. So I'm counting on you. Among the 27 people, we have 5 PhDs. A lot of the founders have over 20 or up to 25 years of experience in telecom in different companies. And the following list are the list of awards that we got as a company. So we were awarded by France a grant for the Plan de Relance for the ILAO 2022 competition. We're also part of the French Tech DeepNum 20. That's the list of the 20 most promising companies in the digital world. We're also part of the Innovation Lab Accelerator from the US, 5G Open Innovation Lab, that gives us access to also a lot of partners and a lot of information exchanges with big players of 5G. We are part of the 5G Orange Accelerator in France and of the NETVA Deep Tech Accelerator in North America, Atlanta. So that's Firecell. Now, why private 5G networks? Firecell is focused on providing 5G for private networks and for the industry. Industry 4.0 has a huge need for communications that need to cover all their premises 100%, indoor and outdoor, with a quality of service that can be controlled, and with the utmost security. The Industry 4.0 has lots of items that need to be controlled, lots of data that needs to be communicated fast from the offices to the warehouses, from the control centers to the machines. They can be AGVs that are automatic guided vehicles. They can be robos. There can be sensors. There can be drones. There can be logistics with boxes or containers that are need to be localized. All this needs a network that fulfills a lot of requirements, and that has to be independent from the public, also public telco network. They need to have their own network that's as efficient as the public telco network. Well, we believe that private 5G is a game changer for enterprises because, first of all, it brings performance. 5G uses 5 to 6 times less access points or radio units than Wi-Fi. That means that it's much easier to deploy, it's much less expensive, and it's also much easier to maintain. You have less cables, less units, less maintenance. Reliability. 5G can be as robust and as reliable as Ethernet when it's well installed. So you can be very sure about the quality of the network once you have correctly installed 5G. Mobility is also part of the solution. Cell handover is natively supported. Cell handover is what happens when you move from one cell to another. All your context, all the information, all the data that you're currently receiving from one cell, you must continue receiving it from the other cell. Well, operators have worked on those solutions for years, and it's completely part of 5G and very efficient. Flexibility is also one of the key promises of 5G, because with one single 5G network, you can connect your industry for multiple use cases. You don't need multiple networks, you just need one. And it can adapt to all kinds of use cases, whether they use very high bandwidth that you have not been able to use before, over the gigabits per second, or it can be also sensors which send very little data. You can have use cases that need a lot of a very low latency, or some use cases don't need latency. You can split your network into different areas that are completely independent, where you can ensure a stronger security and a division between different parts of your industry. You will not want, for instance, people who are working in administration to be able to connect to the part of the industry that controls the robos, for example. So 5G allows this also to split your network into different completely closed networks. So security is very important. We live in a world where there's cyber attacks are constantly ongoing, and having a private 5G that is controlled and properly managed, well, is a guarantee for the security of your premises. First of all, 5G encrypts all communications natively with the best algorithms that are existing, but also authenticates everyone that connects to the network using SIM cards, which are physical devices, or it can be eSIMs, but they're the most efficient way of guaranteeing that the people are actually authorized to enter the network. Let's have a look at a few use cases for the 5G for the industry. One of the most simple use case is building a campus network from nothing. It can be indoor, it could be outdoor. It's very easy to set up robust connectivity with hundreds of simultaneous connections, very high bit rates. You can install it in one day, and you only need one single radio for a relatively large campus. That's very easy to set up with only one radio, very efficient. Then another interesting use case is about security. Here you have a picture of the connected camera. This is a use case that really makes sense in 5G, because instead of pulling wires to connect your cameras, you will just put them wherever you want in the wireless network. So you can deploy it in a few days, and you can also couple it with automatic alerts that would function using artificial intelligence. Very promising use case that works also in cities and also in the industry. Okay, you can track and monitor whatever's going on in the industry, provide data, or just detect abnormal events to be able to alert the people, the managers, that something's not going well inside your industry. So this is a very interesting use case. We also have smart logistics. Picking consists in moving and grabbing items from stocks. 5G is for the industry 4.0 is very useful for this kinds of use case, where robos can be connected to the network and instructed to get different items, whatever they are. So with 5G, you can cut downtime because you have a very reliable network. You can save hours of workers' efforts because you automatize everything. It works where in areas where Wi-Fi doesn't work, like heavy metallic areas, and it works with all kinds of goods. A very promising use case, picking. If you've ever ordered at Amazon, picking is what they do all the time, every day. Smart tools, that's another use case that we've been working on since we created Firecell. Indoor tracking is one of the futuristic use cases of 5G that's coming soon. It allows you to benefit from the triangulation algorithms when using different antennas and different radio units to precisely locate all the user equipment that have connected to the network. We use this in a project to connect tools such as screwdrivers. Those screwdrivers are connected to the network. They send data. This person, for instance, is screwing a door inside a car, while the quality of the final quality of the car that is produced in this industry depends on all the parameters that are going to be detected by all the different tools that are involved in building this car. So it's very important to be able to connect all the tools of the industry and also to locate them for different use cases, either to be able to know where they are, exactly, of course, to locate them, to know where they are in the flow of data, and also to implement geofencing. That is a way to prevent the tools from working or for alerting whenever the tools are not in the area where they're supposed to be, to prevent accidents and to make sure also that the quality of the building of whatever you're doing, the quality of your industry is followed precisely. So this is very promising, and Firecell is working on a few innovative projects using indoor tracking. It's interesting to note that the tracking is done without beacons, without GPS, only using 5G network and a few antennas. Finally, one of the last use cases that I will mention to you is mobility in 5G using TSN, time-sensitive network, to control machines that require very low bandwidth. So you can control industrial equipment, you can plan, stop, reroute AGVs that are automated guided vehicles. You can monitor and control industrial robots in real time, all this using 5G. What kind of industrial 5G user equipment do we have access today? Well, on top here, you have an example of development boards on the top of the picture that we use very frequently. This one is from, this picture is a board developed by Quectel, and it's made for developers. You need to download a specific application and you send AT commands to the modem, and you control exactly what the board sends like messages and receives from the network. So it's very useful to implement whatever you want to do precisely using 5G. Then we have ruggedized smartphones. The model we have here is called Core Z5. It's the first 5G ruggedized smartphone developed by a French company called Crosscall, and it works beautifully. It's ruggedized. That means that if you drop it, or if it falls into water, or if it falls in dust, it's made for resisting all this. So particularly useful for the industry. We have industrial routers that are compatible. Here I presented two models. One is from Advantech, the black one, and one is from a Latvian company called Teltonika, and it's the white and blue one. We also have connected cameras for the use case that I already presented before, and there are more and more coming. There are sensors using 5G, there are scanners, barcode scanners that can use 5G. So there's a real ecosystem that's being built for the industry. Now, why open source? We at Firecell, we built the company, as I told you before, with Eurocom, and Eurocom has created software since 2014 that they have developed at that time 3G, then 4G, now 5G, and guess what? They're already working on 6G. But let's focus on 5G. Eurocom has developed this open air interface, and it's managed by an organization that's a nonprofit organization called Open Air Interface Software Association, which has over 200 members. Among those members, well, there are small companies like Firecell, but there are little bigger companies like Meta, Facebook, Qualcomm, Vodafone, Orange, Nokia. All those companies are members and are contributors to the open source code that's called Open Air Interface. The open source code implements both the 5G core and the 5G RAN. That means with the Open Air Interface, you get a full solution to be able to implement 5G, and it supports Open RAN. Nice thing about it is that it's open source using the Apache v2 license, which means you're free to use it, to contribute, and whatever you do with it, you can integrate it in your own product, whether you sell them or not. So it's a very free and open license. Open Air Interface and Open RAN. Here are a few announcements that they did last month in March 2023. So at the Mobile World Congress in Barcelona on the 2nd of March, they demonstrated Open Air Interface, demonstrated Open RAN integration using 7.2 front haul split. I'll tell you a little more about it later, over the air. Okay, they were using a 250 milliwatt indoor ORU, that means Open RAN radio unit, from an Indian company called VVDN Technologies. They were able to send up to 8 layers of uncompressed IQ samples. So those are the samples that you send to the radio, ready to be transmitted as radio signals. Each of them using 100 megahertz bandwidth over 25 gigabit per second interface. The SCS, which is the delta between the different layers, was 30 kilohertz, and the TD mode 2.5 milliseconds DDDSU. That means 3 downlinks for 1 uplink, and the band used was N78, which is centered at 3.5 gigahertz. Okay, CSC is for subcarrier spacing. Sorry about that. Subcarrier spacing, 30 kilohertz. So what kind of 5G user equipment they used for the demo? A Quectel development board that I told you about before, that was enclosed in a Faraday cage in order not to get interference from the outside world. And they achieved a bitrate of 600 megabits per second downlink using MIMO 2.2. So sending twice and receiving twice using the antenna, using two antennas. And I believe they're still working on the version that will be compatible with MIMO 4.4, and hopefully to be able to double the achieved bitrate over 1 gigabits per second. On the 16th of March, OAI announced a memorandum of understanding, that means an alliance between ORAN and OAI. That means that they'll be working together in promoting open software, open source software, and open interfaces between all the components of the 5G network. So this is very good news, and this is very interesting for Firecell, because we focus, our products are based on open air interface, and we are advocates of Open RAN. Let's dive a little bit into a technical diagram. You might be acquainted with this one. It's the different split options that were defined by 3GPP for disaggregating the radio access network. Historically, radio access network was monolithic. That meant that you had to buy a big block with everything inside from only one vendor. Well, 3GPP has standardized different options of splitting a RAN into different parts from 1 to 8. And we'll focus on option 2, front haul, and option 7, split 7.2. So the options differ in how you split the functions between different boxes, where you will put the RLC, the radio link control, or the MAC, the medium access control, the PDCP, the packet data control protocol, the RRC, radio resource control, okay, up to the RF, which is the radio unit. So up until now, you had the BBU, that was everything before option 8, and the radio unit. There was hardly any processing inside the radio unit. Well, that has changed completely now, and more radio units are integrating processing power that will allow more flexibility in implementing your radio access network. So thanks to this, Open RAN has further defined interfaces using the split defined by 3GPP, and you get different architecture options. If you start from the top, you can have one box with everything inside. So it's called a small cell. You will have the PDCP, RRC, RLC, and MAC. The interface with the physical layer will be hidden because it will be inside the same box. And you have something that you can call integrated, all-in-one, or small cell, where you have the radio and everything up to the G-Node B inside one box. That could be quite useful in some use cases. But you can also disaggregate the RAN into 2 different units, either using split 7.2, 7.2x, because there are 2 options, A or B, where you would have on the left-hand side the one box containing the G-Node B, split into CU, DU, but inside one box. CU is for centralized unit, DU is for distributed unit, and on the other side, the radio unit. So one box with a PC with the G-Node B composed of CU and DU, and one box, which is the radio unit, compatible with Open RAN, and the interface is called front haul interface or split 7.2 interface, and has been standardized by Open RAN. That means that if you have your box, you can use any Open RAN radio unit that you want. You don't have to get them all from the same vendor. On the third line, you see another kind of architecture where you have the G-Node B centralized unit that's separated from the G-Node B distributed unit. CU, DU are separated by a front hall interface using by a F1 interface, called split 2, in reference to the previous 3GPP diagram. And finally, you could also have a 3-unit disaggregated RAN where you have both split 2 and split 7.2. You have CU in one box. When I say box, I mean a PC, a rack, or a virtual RAN, virtual CU, the DU in another box, and the RU in another box. Which of those architectures you will choose depends on the site, depends on the cables that are already there, depends on the distances, depends really on the topology of the site. There's not one solution that fits all. So that's very useful to be able to choose your architecture, to be able to split the components the way you want, all that using standard interfaces. Now, if you are a geek and you're interested in getting access to the OpenAir interface, well, it's free, it's open. Just connect to the gitlab.eurocom.fr website, go to OAI/OpenAir interface 5G, and you'll have access to the OpenAir interface 5G RAN and core. You can download everything on your Ubuntu Linux PC, compile it, and make it work either with simulators or with software-defined radios, or with your own Open RAN radio if you have one. So I encourage you, if you're interested, to look at the source code, and you'll learn a lot about it. You'll learn a lot from it, and you can also contribute. But if you're not a geek, and if you're an industry and you want to have something that's ready-made, well, that's what Lab Firecell is for. Our job here is to, a bit like Red Hat does for Linux. Linux is free. Red Hat provides support for people who want to have professional versions of Linux. Well, that's what we do. We currently have 2 products. One that's dedicated to R&D labs, universities, innovation centers. It's composed of a PC in a box, an Open RAN indoor radio unit, a ruggedized smartphone. It's compact. It's very easy to unbox, plug in, press the button, start, and you have a 5G network that's running. You can do your tests. You can also, it comes with Wireshark pre-installed. That means you can look at the protocols, the message exchanges. We sell a lot to universities, and our customers love it because it's cheap and easy to use and pre-integrated. Then on the right-hand side of this slide, you see another product that is made for deployment. It's called Orion Private 5G, and it's dedicated for the industry. Warehouses, factories, campuses, offices, spaces. It comes with a rack unit PC, and then you can choose the architecture you want. By default, you'll have the CU and the DU inside the PC. So it constitutes a G-Node B, and an Open RAN radio unit that can be indoor or outdoor. And all the SIM cards are provided also, so that you can start building your network using your own devices, or one of the devices that we previously saw, cameras, boards, routers, depending on what you want to do with it in your industry. Okay, so as a conclusion, 5G private networks is great with open source and Open RAN. So that's what I wanted to advocate today with you for those 4 reasons. Number 1, you can adapt your architecture to the topology of your network where you're going to actually implement it. You can choose between all-in-one or disaggregated RANs according to the use case and the topology. If you have lots of RANs, if you have lots of cables, some architectures will be more adapted. Think about it. Then open source is great because R&D is faster and is cheaper. It can be cash efficient. It's faster to develop new features thanks to a thriving community of people who are members of the Open Air interface. Open RAN is a great way to lower the overall network costs because it encourages competition, it encourages integration between different components, and it's absolutely marvelous because people, different vendors can provide just the part that they're specialized in, and you can pick and choose the components that best match your actual requirements without caring about the APIs because they're all standard. Finally, well, what's great with open source is also you can contribute and implement advanced industry features. And that's what we strive to do at FireCell. We want our customers to benefit from advanced features that are complex to develop, and leveraging on the open source. We are currently building geolocation, time-sensitive networks, and other upcoming features that are quite fascinating and that are part of the 5G promises compared to 4G and compared to Wi-Fi. Thank you very much for following this presentation. I hope you enjoyed it, and I hope you learned some things.
Read one question from Carlos Saul Perez. His question: how about devices with 5G RedCap? When do you expect that they will be available? So for the participants, RedCap is reduced capability of a 5G UE equipment, UE device. So he's asking, Nicholas, yeah.
I can tell you when we have it in our roadmap, and it's planned for us in 2025 to be ready.
Mm-hmm.
That doesn't mean that other vendors will not have some before, but we plan it to have available in our portfolio in 2025.
Great. Thank you. Question from JR Gamo. How about IoT with 5G? His question is not quite complete, but probably if your equipment might be supporting IoT.
Yes. So IoT with 5G is something we're working on because it requires, I'd say it would require very low latency. So it's one of the use cases that is called RRLC. I forgot how many R's there are in there. So very reliable, low latency communication. That's something that we're working on, and it would be available in 2024 regarding FireCell.
Mm-hmm. Okay.
One of the limitations that we have is also to find the right devices. It's important. We work mostly on the server side, and we're of course being very careful at looking at the devices that are available to start doing IoT.
Okay. Next question from John Paul Paga. Is deploying private 5G network warrants NTC approval? But NTC is something like a FCC.
Yes.
Here in the Philippines.
Yes. So to deploy private 5G networks, I didn't mention this, but it's a very, very good question. You actually need your local authorities to allow you to access the frequency.
Mm-hmm.
So in many countries, the authorities have unblocked or reserved frequencies for private networks. And all you need to do usually is to apply to be able to use this network in the country where you want to develop it. And I don't know about NTC, but FCC is in the US the organism that validates that your equipment is conformant with the rules, not only in terms of security, but also in terms of performance and respect of the frequencies and of the norms, the standards that are fixed by the country. And yes, we are currently working for FCC. We are already approved for the European market, CE, and companies that will want to work in the Philippines will have to get NTC approval, definitely.
Great. Okay, next question from Arnel Gruspe. Is Open Air interface available to download as a virtual machine for EVNG? That way we can test and play on how the firmware works without purchasing expensive hardware.
So I'll have to admit that my technical limitations will not allow to answer completely this question. I've never heard of EVNG before, but I know that the Open Air interface is available as containers, and that means that it should work with Docker, and it should work on any kind of virtual machine. But specifically about EVNG, I will check, and I'll see if I can answer you offline, or you may ask the community directly of Open Air interface.
Okay.
Sorry, I can't answer better.
Follow-up question from him. How much is the cheapest FireCell lab kit? And can we build our own lab kit? If so, what are the hardware components? So
we at FireCell, we provide, and you can have a look at the website where you'll see the prices, and you can order directly from the website a lab kit. And if you want to make your own lab kit, let's say the equivalent from Open Air interface, you're free to download the source code from Open Air interface and choose the equipment that looks that is the same as the one we use. That's absolutely possible.
From Russell Kirby Rivero, is Open RAN's 5G protocol the same with the 5G protocol that Huawei first released back then? Or are they competing protocols? I'm curious because I've read somewhere that Huawei currently has a large market share, so I'm curious of their compatibility.
Well, 5G for operators makes sense only if once you have the network deployed, all the user equipment, that means the smartphones, work on this network. So no one will build a non-compliant 5G network because I believe it won't work with other equipment. So my opinion is that Huawei's 5G network is compliant with 3GPP and would work with any device, should work with any device that is compliant with 3GPP.
From Matthew Fernandez, how can private 5G networks be integrated with existing enterprise networks and IT infrastructure? Or what are the best practices for doing so?
Well, you have the choice, of course, between building a complete 5G network that's independent from an existing enterprise networks and IT infrastructure. Okay, of course, the idea is not to replace an existing IT infrastructure if it's there, but to be able to complement it with a wireless network. So the objective is to be able to integrate it with the current wireless network, and everything is there are tools, there are modules that allow you to connect the core inside the core network to make it work with the rest of the enterprise. It might require some IT knowledge in order to do this well, but it would be long to discuss about the best practices, but it's something that we can start discussing offline, Matthew.
Okay. Thank you, Nicolas. From Carlo Amigable, for 5G lab use in the universities, do they need to apply for the licenses? I think this was already answered.
Yes.
Previously, yep.
Yeah. Well, to make it to complete my answer, if it's indoor, in most cases, the regulators will not. In most cases, but it needs to be checked. If you do it indoor, and it's your own premises, normally no one will bother you. But if it's outdoor, yes, you need to, of course, to make sure you use a frequency that is allowed and that you have the authorization to use it. so that someone else doesn't use it instead of you,
Mhm.
and make sure you don't interfere with other people, but also with eventually with if you're close to an airport, or if the firemen use the same frequency as you, that's something that has to be regulated for obvious reasons.
Mhm. Okay. Um, Question from Hernani Mendoza. So how can you relate 5G and Tetra radio?
Maybe I'm mistaken, but it might be analog. It has started to be replaced by 4G, mission critical, and the equivalent is available in 5G. Absolutely, it's called MCX over 5G, and it replaces 4G, and it works beautifully too. So we're currently also at Farcell working for 2024 to implement mission critical communications over 5G. And one of the smartphones, ruggedized smartphones I showed you, is quite perfect for this kind of implementations.
Okay. From Jen Andal. What are the key features and capabilities of FireCell's lab kit for testing and validating Open RAN and 5G networks, and how has it been received by customers and partners so far?
Okay. Well, thank you for asking. As I told you, we've been very successful in selling lab kits because it was one of the first complete platforms that allowed people to have a 5G network at home or in their lab. So it contained everything. First, we provided LabKit with an SDR, software-defined radio, which meant that it was not Open RAN. And now we provide a LabKit that's compatible with Open RAN, which means we can deliver it with a radio unit, and from there, well, you can test all the interfaces either by tracking the source code in real time, or by using Wireshark to look at all the protocol exchanges. Wireshark is pre-installed on LabKit, and it's with all the filters. We have documentation that's included with LabKit that shows you how to manage the filters of Wireshark and see all the exchanges between all the different components of the core network and of the RAN up to the UE. It's very instructive. I can share some screenshots if you want to show you how it looks, what it looks like. Can you see it now?
Yep.
Okay, so this is a screenshot of a Wireshark session where you see the messages sent on LabKit between all the different components of the core network, the SMF, NRF, UPF, to the GNode B, up to the UE. So for those of you who are familiar with the 3GPP messages, you'll recognize some requests and some protocols.
From Ronald Balinas, is 5G Open RAN only applicable for 5G SA? Also, do we have list of vendors supporting the 5G ORAN? And not all major vendors support 5G ORAN.
So does 5G ORAN, is it applicable only for 5G SA? Meaning, does it work for 5G NSA?
SA, the standalone there.
Yes, non-standalone. My understanding is that Open RAN is 5G mostly, and and therefore most of the radio units, for instance, will be 5G. And if you want to do NSA, you'll need two radio units, one for 5G and for the data, and one for 4G for the control. So I believe that non-standalone is not really compliant with Open RAN. Now, regarding a list of vendors supporting 5G or RAN, you should go to the ORAN website. There are all listed over there. And of course, not all major vendors support 5G or RAN because, well, some vendors were not very happy about inciting competition and about splitting their their solution to smaller pieces and risking reducing their market share. So, but I think even all the vendors that do not support it completely are progressively changing their mind because they see it's a trend.
But yeah, in the recent memorandum of understanding with the European operators, what they have prioritized towards the equipment vendors of the Open RAN, they are preferring to have an SA and non-standalone. So both modes of 5G, they would like to have it in the Open RAN.
I'd like to have both. Okay, I didn't know that. Okay, great.
Okay.
Thank you.
Coming from Johnny Gonzalez, how does the time-sensitive network works? I think it's
So I don't really know how it works, but I know it depends on two things. First of all, to have a very low latency to be able to implement those time-sensitive use cases, and also to have a shared a shared unique time protocol. And I believe also, but I might be confusing with ultra reliable latency, where you would need to have redundancy to make sure that the solution is provides 99% with a lot of nines efficiency. But yeah, I guess it's all I can say about it at this stage.
Yep. Is there a difference in 5G connectivity between mid-range smartphones and high-end smartphones?
I would suppose so, but we are doing lots of tests and we see differences. Yes, it's quite obvious that the better the antenna, the better the quality, the better the reception you get. So it's the same also on the other side. If you have a radio access network that works with good antennas, that is well implemented, you get a better quality. It's the same for the UEs, definitely.
Yeah. If you have a higher specs of phone, you will have a better experience with that one.
Yes, that's correct.
All right, so I think that's for the Q&A portion. Thank you so much, Nicholas.